All right. We did last time, we talked about points and discussed what graphs are, and we went as far as defining a slope. How much do you remember of that? How do you find a slope? Yes, that's what it defines it. But how do you find it? 2 points. Okay. To find the slope, you need 2 points. Let's say that I give you 1, 3, and 5, -8. That might make a -9. Make it an easy one. Okay, that's our first thing. You need 2 points. What's the next thing you do? I'll put the steps over here. Find M. What else do you have to do? Yes, but before you plug into value, what do you have to do? What did you say? Very good. That's exactly what you should always do. Label the 2 points. Because I guarantee you, I've seen too many times where students don't label their points and they just start reusing the points or put them in the wrong order. What I mean by label the 2 points is we have to find x1, x2, y1, y2. We have to find all those values. So our step 2 is x1, x2, y1, y2. And another thing we have to do is label the 2 points. We let those label the components of the 2 points. But this is our first point. We can define it however you want to. But this is our first point. And this is our second point. All this stuff is what we define as labeling the 2 points. So what is x1? It's the x value of the first point. What is x2? Now, what is the x value of the second point? This is x1, this is x2. So that this is y1 and this is y2. So y1 is 3 and y2. Step 3. What's step 3? Okay. Plug and play. Plug them into the formula. Since we're looking for the slope, it's y2 minus y1 over x2 minus x1. It's a good practice. It's a good practice. Whenever you use a formula, always write down the formula in your question that you're writing out to get it easily memorized, and it's much easier so you don't mess up. So in our equation, what is y2? -9 minus y1, 3. x2 minus x1. Because all you have to do is just plug in these values here. Leave these symbols where they are. Now just work them out. -9 minus 3. They're both negatives, so it's negative. Add the two numbers. -12. 5 minus 1. So the answer is it positive or negative? Yeah, because whenever you have multiplication and division, I'll talk about this in a little bit later on today also. But anyway, whenever you have multiplication and division, count the number of negatives that you have. If you have an odd number of negatives, the answer is negative. If you have an odd number of negatives, the answer is negative. 1 is odd, so the answer is negative. 12 divided by 4 is 3, so that's our slope. What if I give you a graph? Can you tell me the slope? Let's see. If given a graph, find the slope. There's the graph of a line. Now find the slope. There are two ways to do it. Can you figure out either of them? First off, label the points. What's that location? -3, comma, -2. Very good. It's back 3, down 2. And what's this location? So yeah, if you have graph paper, it's much easier. So okay, we label the points. There are two ways you can do this. What are they? You can choose either way to find me the slope. Exactly. You can use the formula we just used. Right. That's one way. What's another way? Count. Exactly. Because what is slope? Slope is rise over run, right? So how far does it go from this point to this point? Oh, this point here. How far does it go from this one to that one? 1, 2, 3, 4, 5. So it goes up. It's positive. It goes up. It goes 5. And the bottom is what? How far it goes from here to here. 1, 2, 3, 4, 5, 6, 7, 8. There you have it. Just count them. If I give you a graph, it's much easier if you just count it a lot of times. Which way is more accurate? Right, the counting. Because you can always make mistakes with negative signs. If you think about it, I mean, look at this one's got 2 negatives. What if this one had negatives? So, but you should know how to do it both ways. If I give you a graph, you just count. How far is it from this point to this point? So I go up 1, 2, 3. So up 1, 2, 3, 4, 5. So that's how high they are, and then how wide they are. So far, so good. There's a third way, but we'll get to later on. It's using an equation. Because you won't always get a graph or just 2 points. I may just give you a formula, an equation. And from there, you have to interpret what that equation says and tell me what the slope is from that one. And we'll do that in a second. What are intercepts? When we say intercepts, what are we talking about? Exactly. Where the graph crosses the X and or Y axis. Because there are 3 possibilities here when it comes to lines. Those are the 3 possibilities of your graphs. This is the line, this is the line, and this is the line I'm talking about. Okay, the first one, it could be positive or it could be negative. It could be either one of those. This is line 1, this is line 2. Basically, what I'm saying is they just have a definite slope. So our first one we're used to seeing some of this is there's a line that has some kind of gradient, some kind of slope. You can have a horizontal line. Horizontal is going left and right only. Or you can have a vertical line. Vertical means go ups and down. Again, it's the words that you have to know. I can tell you a lot of students in the past got confused between horizontal and vertical. If you think about horizontal, what's the horizon? When you look outside, what's the horizon? Anybody hear that word before? The horizon is that far distance you see at the edge of the world. That's the horizon. It's the flat, the horizontal line. That's why it's the horizontal. Vertical goes up and down. Okay, so this is just a regular line. So the intercepts. These 2 points are called what kind of intercepts? What line are they crossing? Yeah, they're crossing the y-axis. So these 2 points are the y-intercepts. The y-intercept is where the line crosses, the graph crosses the y-axis. And then these 2 points are your x-intercepts. It's where it crosses the x-axis. Do you always have to have x and y-intercepts? No, we just prove these other ones. You don't have to. If it's a horizontal line, you only have a y-intercept. You only have a y-intercept. If it's a vertical line, you only have an x-intercept because it only crosses the x-axis. This is the x-axis. This is the y-axis. Does it make sense so far? So if it's a horizontal line, you have a y-intercept, or vertical line, you have x-intercept. This one you have both. Any other line has an x-intercept and a y-intercept. Because this is going to be important when we start talking about equations of lines as well. And this is my line. So what is my x-intercept? Just one. When you ask for the intercept, it's the location. It is one, but what's the location of it? 1, 0. Remember, location is the coordinate of that intercept. It's at 1, 0. What's the y-intercept? 0, 4. Very good. Right, with this graph, what's the x-intercept? 1, 2, 3, 4, 5. And the y-intercept? 0, -3. Yeah, it's a negative side. No, I know. I'm saying that's going to happen also when you write. But yeah, you're absolutely correct. It's 3, but it's -3. So far, so easy. Notice one thing. The x-intercepts. What's always constant in there? In both of these x-intercepts, what number is always the same? Yeah. So in the x-intercept, y is always 0. So in an x-intercept, y is always equal to 0. On a y-intercept, what is true? X is always 0. You see that? I mean, this is important because this will help us find them if I give you an equation. Given this equation, 3x plus 2y equals 6, find me the x-intercept and the y-intercept. Pretty easy. It's only 4 steps for both of them, total. 2 each. Actually, it should take you longer to write the question than it is to solve it. All right, let's look at both of these. I have 3x plus 2y equals 6. 3x plus 2y equals 6. To find the x-intercept, what do we have to do first? No, because what do we just talked about it up here. To find the x-intercept, what's always true? For the x-intercept, what's always true? So the first thing you do is set y equal to 0. Two times 0 is what? So that just disappears. What you really have is 3x equals 6. What do you do to solve for x? Yeah, since it's 3 times x, divide both sides by 3. So x is equal to 2. So the x-intercept is at 2, 0. This is important. So to find the y-intercept, what do we do? Set x equal to 0. Three times 0 is 0. It disappears. So we have 2y equals 6. Divide both sides by 2. Y equals 3. So there's your y-intercept. With practice, you'll be able to skip some of these steps. For the x-intercept, anywhere you see with anything with a y, just erase it. Just erase it, and you should only be left with x in your equation. You're looking for the x-intercept. Let's do another one. Yeah. The x-intercept equals and the y-intercept equals. All right, so let's get the x-intercept and the y-intercept. I'll put the steps here also. To find the intercepts. Step one. This is for the x-intercept. The first thing you do is set y equal to 0. Because since we're looking for the x-intercept, we don't want the value of y anywhere in there. So we set y equal to 0, or basically what we're talking about here is just erase it. Anything with an y, we just get rid of it. Because 5 times 0 is 0, it disappears. Then we do what? Divide by 4. So we have x equals 9 over 4. And right now, I'm happy with that answer. We'll talk about fixing it in a little bit. So that set y equals 0, solve for x. Do the same thing with the y-intercept. But here, we set x equal to 0. Or just get rid of anywhere you see an x, just get rid of it. Because 4 times 0 is 0, it just disappears. And then solve for y. So we have to divide by 5. Pretty straightforward. So the answer for the first one, what is the x-intercept? Nine over 4, comma 0. That's the x-intercept. It's the location. And then for the y-intercept, right. And here's the problem with computerized homework assignments. Sometimes they'll accept that as an answer. As 9 over 4 as an answer. Yes, it's a fraction. And fractions are more accurate than decimals. But it's an improper fraction. Why is it improper? Well, yeah, because the top number should always be bigger than the bottom number. I mean, it should never be bigger than the bottom number. The bigger number should be on the bottom. It's improper because the top number is bigger than the bottom. So what we have to do here then we have to change it to what's called a mixed number. A mixed number has a number in front and then a fraction. So we're going to have our integer here. The bottom number will always be the same. The bottom number in your answer is going to be the same. So that's given to us. What we have to do is figure out how many times does the bottom number fit to the top? 2 times. 4 times 2 is 8. So how many is left over? And that's how you do it. And now you have a mixed number, which is an integer with a proper fraction. This is where knowing your multiplication table is a lot easier in the long run. Does that negative in front do anything to the answer? No, it just tells us if this question is negative, the answer is negative. It doesn't do anything else to the numbers. How many times does 3 go into 29? Yeah, 9 times 3 is 27. 10 times 3 is 30. That one's too big. So it has to be 9. So we know it goes in there 9 times. So what's the difference between 29 and 27? We have 2 left over. And there's your answer. There's your converted form. Y'all remember that from high school? From junior high? Most people said no because, again, you aren't used to seeing fractions. You're used to seeing decimals, whatever's on the screen on like a calculator. But in here, I would rather you guys only use calculators to check your answers, not replace them. Because all your answers, I want them in fractions, not decimals. All right, so everybody's okay with the process of finding the intercepts. Obviously, we wouldn't use this because we can use the intercept method to graph equations, but we wouldn't use it because of these. How would you plot 2 1/4? No, you wouldn't, because it wouldn't be accurate. You in mathematics, you have to be precise. So we wouldn't use this because this number here is too hard to graph. Let's get back to our first one we did. Graph using the intercepts. So using the intercepts, that means we have to first find the x-intercept, and then we have to find the y-intercept. We'll write the equation down for both of those. How do you find the x-intercept? Yeah, set y equal to 0. So get rid of the y. So we have 3x equals 6. Solve for x. Why do I divide by 3? And why do I divide instead of subtract? Yeah, because it's opposite. How are 3 and x connected? Multiplication. This is 3 times x. So opposite multiplication is division. So I divide by 3 both sides. 6 divided by 3 is 2. So that location is 2, 0. That x-intercept is 2, 0. Do the same thing with the y-intercept. With the y-intercept, get rid of the x, because we only want the y value. So erase anything with x, we get rid of it. This is 2 times y, so opposite of times is divide. Divide both sides by 2. So your location is 0, 3. That's the first step. Can we plot those? Two, 0. That's the first one. That's the x-intercept. 0 up 3. And connect the dots. And there's your graph. So if the intercepts work, great. Plot them both and you're ready to go. But if both of these numbers, one or both aren't nice, then you can't use the intercept method. So here. If both intercepts are integers, that means numbers, then plot those points and connect the dots. So the intercept method works if and only if this works. So if one or both intercepts are not integers, means we can't put them on a solid dot, then we use another method. And here we're going to talk about those. Let's try this one. 3x plus 5y equals 6. Yes. So in this one, that one works. But this one, nope. Because again, it's hard to remember how close the dots are on your graph.
Like 1.5.
Yeah, then it's iffy because remember, it's only as your answer is only as accurate as your graph is. And if your whole grade is acting upon that one graph, if you're off by just a little bit. Yeah, but you're right. You think it's 1/2 is just put it in perfectly. But remember, on the graphs on the computer, those lines are pretty close together and putting it inside. So this one, since it's not an integer, we can't use the graphing method. I mean the intercept method. So here, the steps. If only one intercept is an integer. So if only one intercept's an integer, Step one. Plot that intercept. Then from that point, or from that equation, I should say, from that equation, we try to find another point that will work. So we know we can use that one. What we have to do now is we have to find another point. So what value of X can we put in there that we can solve for Y? What that means is find a value for, in this case, since we have an X-intercept for X, that will make finding Y easy. Since we know that X works, we have an X-intercept. We have to find the Y-intercept now. So we have to find an X value that when we solve this equation, oops, this should be 5. We have to find an X value, plug it in there so that when we move everything around, we can solve for X. The coefficient of X is a 5. What does that tell us? If we're solving for 5y equals whatever numbers on this side has to be divisible by 5. What numbers are those? What numbers are divisible by 5? 5, 10, 15, 20, 25, 30, 35, 40. So what we have to do is somehow get a number here that when we move it over this side, it's going to give us a solid answer. That's easy divisible. For example, if we have 6 here, and if this is 24, 6 plus 24 is what? It's 30. So if X is a negative 8, if X equals negative 8, and we plug it in there, 3 times negative 8 is what? Negative 24. Now we have to get the Y by itself, so we have to get rid of this one. How do we get rid of the negative 24? Add 24. (24 plus 6 is? Now divide by 5. 30 divided by 5 is? So we know a point that works is negative 8, comma 6. No calculators. You don't need calculators in this room or cell phones. Because if you think about this, we know that 2 comma 0 works. That's an X-intercept. We know that negative 8, 1, 2, 3, 4, 5, 6, 7, 8, up 6. We know that one works. So if we connect them, there's our graph. That's only if you can find something that works. Not good method, is it? Let's see if there's another method we can use. If we had the slope, would that help? Finding or graphing equations using their slope. Because if we don't have 2 points, as long as we have a point and a slope, I can tell you the equation of the line. I can tell you the graph. I can tell you everything about that graph equation. If we know a point and the slope of the line, then we could find the equation of the line and the graph of the equation. So if we know a point and the slope, since we're only dealing with graphs, we can graph that equation. Here's an example. I have a point, or my x-intercept. I have the slope is 3, 4. I'm asked to graph the line. Here are the steps. First step. Plot the point. So the only point we have is at 2, 0, so we put a dot there. From that point, follow the slope to the next point. Because remember, the slope of a line means that that's the relationship between each point on that graph. So in other words, the slope is 3 over 4. From this point, from 2, 0, the top is rise and the bottom is run. Since it's positive, I go up. If it's negative, I go down, and always to the right. So from this point, I go up 3. 1, 2, 3. And then over 4. 1, 2, 3, 4. And there's my next point. Now I connect the dots. And there's my graph of that information. Pretty straightforward. Yeah, so if you have one point and you know the slope, then you can just plot the point and follow the slope to the next point. We can use the slope to the next point. From this one, I go up 3 and over 4. 1, 2, 3, 4. Up 3, over 4. Up 3. So it's always going to be the same. So that's if we know one point and the slope. If we have 2 points, can we do it? No, just 2 points. If we have 2 points, just graph them and connect the dots. So that's all you need. Here's another example. Finding the slope from an equation. Finding the slope from an equation. We're going to progress to, we're going to a whole bunch of different types. But right now, all of our graphs are straight lines. All of our graphs so far are called linear equations. A linear equation is an equation of a line. That's important because all of our points are connected by the same slope. Linear equations have this form. We can have that form. This is called the standard form. Where x and y on the same side. The coefficient of x is positive, and the numbers on the other side. That's the first form. We have this next one called the point slope form. Where your point is x1, y1, and the slope is m. Just plug it in there. And the last one we have is one we'll use most of than anything. This is called the slope-intercept form. You have the slope, which is m, and the intercept is the y-intercept, which is the b value. That value. In other words, this is the one we'll be using more than anything. Because once you can put it in this form, get the solve for y, whatever is in front of your x, that's your slope. Whatever number is by itself, that's your y-intercept. So let's go ahead and solve for this one. Solve for y. In order to solve for y, what do you have to do first? If you're solving for y, what do you have to do first? Yeah, you have to get rid of the x. How do you get rid of the 3x? Nope. Well, we have to move it to the other side. Since it's added to there, we subtract it. This is positive. We subtract 3x from both sides. Because we want to get this whole number to the other side. Because we put a negative 3x. We try and get y by itself. So what do you do now? Divide by 5. Divide each term by 5. Ideally, if everything was perfect, if this was an integer, we would plot that y-intercept on the y-axis and then follow the slope. From that point, we'd go down 3 over 5. Put that, but we can't graph 6 over 5. Do we know any point on that graph so far? Remember this equation? Didn't we solve it for the x-intercept? What's the x-intercept? Yeah, because for the x-intercept, get rid of the y and solve for x. X equals 2. So it's 2 comma 0. So we have a point and we have the slope. That's all we need to graph. So we have a point. This is 3x plus 5y equals 6. So the x-intercept is at 2 comma 0, and the slope is negative 3 over 5. So from this point, what do I do? Go down 3, 1, 2, 3, and 1, 2, 3, 4, 5. And there's my graph. We went down 3 and over 5 to find the next dot. So there's always a way around it. If the equation, remember we solved for y, if that doesn't give you a good point, then find the intercepts. If either the x or the y-intercept give you a solid point, go from there. If that doesn't work, just plug in numbers until you get 2 good points. And that's all there is to it. We'll do a bunch of examples like these. But I want to go back now and finish up our earlier discussion. So I gave you 2 points earlier. If I gave you 2 points, we asked, what can you find with those 2 points? The first thing we found is what? We found the slope. Which was y2 minus y1 over x2 over x1 minus x1. And we found that because horizontally, the line went from here to here, which was x2 minus x1, which was 5 minus 1, which is 4. And then vertically, it goes from here to here, from y2 minus y1, or 4 minus 1, which is 3. So the slope was 3 over 4. It went up 3 and over 4. Now let's look at let's find 2 other equations here. How far is it from this point to that point? From point A to point B? How far is it? Nope. Whenever you ask how far, you're looking for what? Something called the distance. Between 2 points. Actually, you've heard this formula your entire life. Now you're gonna learn how to use it, what it's for. What is that formula? What's the name of it? It's the Pythagorean theorem. A squared plus B squared equals C squared. Pythagoras was a Greek philosopher, mathematician, back like a couple of hundred BC, before they even had paper and pencil. He did a lot of his stuff on the sand. So what he said, he thought this: if I had 2 dots, the distance I go horizontally and then vertically to get to that point is longer than it is if I go this way. True? Yeah. What he said is he called these 2 points the legs of the triangle. We call this A, we call this B, and we call this C. So the square of the 2 legs of the triangle equal the sum of the 2 squares, the sum of the 2 squares equals the square of this number here. It's called the hypotenuse. Hypotenuse. Basically, what the hypotenuse is, it's the distance from this location to this location. So the hypotenuse is the distance from A to B. Does that help us any? Well, hopefully we'll put it together. So in our example up here, where was that one? Not that one. We had an example. Oh, there's right there. This one here. Here's our triangle. This length is side A. It's 4 units long. This is B, and it's 3 units long. We have to find C. That's going to tell us the distance between A and B. So we have 3 squared plus 4 squared, or 4 squared plus 3 squared equals C squared. 3 squared is what? 4 squared is so 9 plus 16. So 9 plus 16 is so is it 25 units from A to B? No, because C is squared. C is this number here. How do we get rid of the square? Opposite of anything squared is square root. Because the square root and the square cancel out. So if we square rooted both of these numbers, the square root and the square cancel, so we get just C. Square root of 25. Does everybody know what the square root means? The square root is looking for what number times itself equals A. The square root of A means what number times itself equals A. So this is A, square root of what number times itself equals 25? 5 times 5 is 25. So the distance between our 2 points is 5 units. So C equals 5. Going back to what we said earlier, if we were going from point A to point B, in cities, if you're driving down 4 miles this way and 3 miles this way, you just drove 7 miles. But if you could take a helicopter or fly, you don't have to go 5 miles. You'd save 2 miles each time. That's what it says. It's shorter going straight line to both dots than it is going the long way around. So remember our equation again. From 1 to 5, 1 to 4. How do we find the distance between these two? Horizontally? This is A. What we did here, this was x2 minus x1. 5 minus 1 equals 4. Vertically, we went 4 minus 1. This was y2 minus y1. This equals 3. This equals C. Everybody okay with these formulas here? Because now we're going to plug it into here. Now we're going to come up with our formula for our distance. Let me move it over here. Let me rewrite it this way. So the C represents what? The hypotenuse. The hypotenuse is the distance. So what we could do is write D for distance. The distance from A to B. It's also our hypotenuse, our C. What is A? A is this distance. So A is x2 minus x1 squared. B is the vertical one. B is y2 minus y1 squared. So to find the distance, we have to square root both sides. The distance formula is this. There is your distance formula. Now you see why I told you all it's important when you first get your points, label them as x1, x2, y1, y2. Now you just plug them in there. Find me the distance between those 2 points. Find me the distance between those 2 points. So the first thing we do is label our points. X1, x2, y1. What is x1? X2, y1, y2. This is 0.1. This is 0.2. Since we're looking for the distance, always start off by writing the formula. X2 minus x1 squared, y2 minus y1 squared. Because once you have the formula, it's just plug and play. X2, 5 minus -3, 5 minus 4. A negative and a negative becomes a positive. So we have 5 plus 3. Five plus 3 is 8. 5 minus 4 is 1. 8 squared. 8 times 8 is 64. 1 squared. Sixty-four plus 1. There's your answer. Again, you don't have to, I don't want decimals, because this is much more accurate than any decimals you can give me. Everybody get this? Everybody not get this? Again, you see how important it is to get back to practicing your multiplication skills. Keep away from that calculator. Get your brain back to working. It's just getting the mush. Let's use it. Okay, so that's the distance between point A and point B. There's another thing we said we could talk about. We have our graph. We have our 2 points, point 1 and point 2. So far, we've discussed, we know the slope of the line. We know the distance between point 1 and point 2. There are 2 more things we need to find. What is the point halfway between point A and point B? That's called a midpoint. It's capital M. And then our last thing is, what is the equation of the line? Because then we have everything we need to know about that line. The midpoint, or the capital letter M. What does midpoint mean? I mean, it's just, what does midpoint mean to you? It's not a trick question. It's midpoint. Is that? Yeah. Exactly, that's it. The point halfway between the 2 endpoints. I mean, it's just not a trick question. A midpoint is just that. Mid means halfway through. That also should give you the hint on how to find it. Example. If you had 2 tests, you made an 80 on one and a 90 on the other. What is your grade for that class so far? How do y'all find out, how do y'all find out what your grades are for the class right now? If you have two tests, what's your grade?
You add them and then you divide by two.
Very good. What's that called?
Add them and divide.
That's called the average. And that's exactly what it is. Very good. You're, what is GPA? You ever hear what GPA is?
Grade.
Grade point average. The grade point average is what your grade is in college after all the courses you take. It's an average of all the classes you've taken and the grades you made in those classes. Your GPA is what employers look at to see whether they want to hire you or not. The higher the GPA, the better you did in school. The better you did in school, the more dedicated you are to finish what you start. If you were an employer, would you want to hire somebody with a low GPA? That tells you that they don't finish what they start. Or if they do finish it, it's not even worth looking at. So it's an average. Add the numbers and divide by the number of grades. In this case, it's only 2. So we have 80 plus 90 divided by 2. 80 plus 90 is half of 17 is 8.5. Or 170 is, because 2 times 80 is 160. 2 times, this is with 80. 2 times 90 is 180. 170 is right in the middle of it. So your average is an 85. What if I had 3 test grades? 70 plus 30 plus 50, right? Now you divide by 3 because you have 3 test grades. 10. Three goes into 15, 5 times goes 0. So that's what it is. It's an average. Since we only have in our graph, we only have how many points? How many points do we have in our graph? We have 2 points. We're finding this one. We only have 2 points. So finding the midpoint. Notice it said midpoint. It's a point. In order to be a point, it has to have a coordinate. Midpoint is a point. So we have to find the average of the x's and the average of the y's. How do we find the average of the x's? You have x1 plus x2. Remember, you add the 2 grades and divide by 2. You add the 2 y grades. And there's your midpoint of that graph. There's your midpoint average. So in our example, in our graph, we had 1, 1, 5, 4. What's the midpoint? What's the midpoint? But I'm glad you said that. It's always gonna be a 0.5. Because you divide by two, always gonna be a 0.5. So yeah, you can put it in a decimal if you want in this case. So what is x1? Yeah, x1 is 1. What's x2? Divided by 2. What is y1? And y2? So 5 plus 1 is 4 plus 1 is 5. 6 divided by 2 is, and half of 5 is, in this case, yeah, it's always gonna be a 0.5. So there's your midpoint. What would be a real world application of midpoint? Why would you need to know the midpoint of anything? One, let's say that, okay, so you have a family emergency at home. Somebody's hurt. And you know the hospital is 10 miles away and they have to send an ambulance. The fastest way to get that person to the hospital is if you met the ambulance halfway. You'd coordinate, okay, let's meet here so that you can transfer them out. Because if the ambulance had to come all the way down there, all the way back, it could be too late. So you'd coordinate, where do we meet halfway through? Okay, the next part is equations of lines. And that's what we started off doing a little bit this morning. But I don't want to jump in because, I mean, if I start now, it'll take us another hour to finish all the examples.